Okay, I think at this point we should get going if we don't want to fall behind things. So yesterday we covered various parts of how to get logged in to ARCHER2, how to transfer data, had an overview of the system, the hardware, the types of nodes that are present on the system. Then after lunch, we covered the module system on ARCHER2 for people coming from the old 4-cabinet small ARCHER2 system or from ARCHER1. It's a little different because you'll now be using lmod to load and manage your modules, and there's this whole concept of hierarchical modules that is new for lmod. For people who haven't used a craze system before, you maybe were able to learn about how to use the programming environment to manage these whole sets of software and switch from one Cray to GNU to AMD toolchain in one go using the CPEs and the plug-env modules. And then finally, to end the day off, we looked at using Slurm on ARCHER2 to write job scripts, how to submit jobs, how to undersubscribe them if you don't want to use the full number of cores on every node. And then we looked at some hopefully useful tips that can be handy when you're trying to develop a code and need to do some debugging or just run some test jobs through running interactive jobs on the nodes and also through using the short QoS. So now here we are on day 2, and we're going to start off by doing some proper dev type work. We'll be looking at how to debug and profile codes on ARCHER2. So I've got my screen set up again. If any of you can't see the writing, please shout out now in the chat and I can zoom in further. Or if you think that you'd like to see more of one screen and less of the other, perhaps I could at least shift it over this way a little for now while we scroll through the material. But on the left again, here's the material you can get on the website. I'll just paste that in the chat now if you want to open that up on your own machine to follow along. There we go. And on the right, I've just got my terminal. Again, my same account as yesterday. This is my account on the course, on the project we have for this course. And I'm logged in again to LN02. Let me just make that a little bigger for you. And at the moment, I'm just in my home directory. So we spoke a little yesterday about what tools are available on ARCHER2. It's different from ARCHER1 in that we don't have ARM Forge anymore, or a linear forge if you knew it from before ARM got it. Again, there is a lot here, more than we can reasonably do in a sort of introduction for developers type course, but there's documentation from Cray. There's documentation we've written for ARCHER2 on the website, and we do also run at least, I think, a profiling course that runs for, I think, either 1 or 2 days. I can't remember, but we do run a profiling course to show you how to do this more in depth on ARCHER2. So I'll start off by looking at the debugging tools that are available on the system. So we've sort of got 5 different packages, if you like, available. All of them are loaded through modules, same as ever. What we'll be looking at is this first tool, GDB for HPC. So if you've used GDB for HPC, GDB before, probably a lot of you have. It's a command line debugger, lets you start tasks, stop tasks, step through them, do back traces if you run into issues, follow variables. GDB for HPC works very similarly, not entirely the same. You can start an internal GDB within it, but on a surface level, it looks very similar. The main difference is that this is special software which has been written specifically to help with running massively parallel applications. So it allows you to launch parallel programs directly onto the compute nodes. That's what we'll be doing. You can also attach to programs that are running, to jobs which are running. If you spot something is having issues, it's got stuck, or you just want to attach and see what's happening, you can attach it to that running job and then start investigating. So we'll be looking at that in a second. Similar to how that's an analog to GDB, we've also got Valgrind for HPC. And this is for memory debugging, but again, it's been written specifically to work for massively parallel applications on a Cray system like this. You load both of those through the modules that you might expect, GDB for HPC, Valgrind for HPC. We have stat, which gives you merge stack traces. If you've got lots of stack traces for lots of, potentially thousands of different tasks, that can be a bit messy to work out what the stack trace for them all looks like. Stat can help with that, and it also comes with some visualization tools. ATP is quite handy. It's something that you just enable at runtime. So you enable in your job script, you load the module and set an environment variable. And then if your code runs into a seg fault or the like and crashes out, ATP will give you a backtrace for it. And you can then check that out using stat. And finally, there's also CCDB, the Cray Comparative Debugger, lets you look at two versions of code side by side to see which changes maybe are causing the issues that you're having to deal with. Just for today, though, in this morning session, we're going to be looking at how to use GDB for HPC to debug an application. So we've got a little test code, so if you all want, you can log on to ARCHER2 just now and we'll work through this together. There's an exercise, I think a couple of exercises up ahead, where it's up to us to use GDB for HPC to work out what's happening. So we've got this buggy code that you can grab from the website. So I'm going to move into my work directory because we'll be running this in parallel. So that means we need to build the executable and run it from our work directory. Remember, because the home directory is not visible, it isn't mounted on the compute nodes. So we have to work in work. So I'll just quickly make a new directory and I'll call it GDB for HPC exercise, which is actually what I've called the file itself. So let's just do some slightly redundant naming here, and then we'll just run wget on the file that's on the website to download it. And if I just do, let's just quickly do vim, or I'll just do less on GDB. We'll see, here's our code. So we're going to build this. There are some problems in it. We're going to find them and fix them with GDB for HPC. So yes, you might be able to see just by looking at it what the issues are. They're fairly obvious, but we're going to try and track them down with GDB for HPC. So we're going to build the code. So we want to give it the -G flag to add the debugging symbols to the binary, and we're going to just name the executable GDB exercise. And remember, on ARCHER2, whenever we build, we want to use the compiler wrappers. So at the moment, if I just do ML to show you the modules we have the Cray compiler environment loaded. We're in progenv Cray. So we'll be building using the Cray compilers. So that means when I do cc-g gdb for hpc exercise.c-o gdb exercise, we'll be building it with the Cray compilers. So I'll just run that like so. And now we've got our executable. So yeah, you can change the name. You can use whichever names you like. Now we're going to get GDB for HPC loaded so we can use it. So now we can start up GDB for HPC. Did I? Oh, because I didn't do module load GDB for HPC. There we go. Or alternatively, just ML GDB for HPC. So here you can see we've got it started. After the copyright information, we just get a little command line prompt. So there are a few ways to load GDB for HPC. I'll talk about another couple of ways after we finish. But just for now, we're going to use the model where we're actually going to launch the execution from within GDB for HPC. Because it's a parallel application, we're going to have to provide information for Slurm so that Slurm knows how to launch it. So it starts off fairly simple. We just give it the launch command, but then we need to give it launcher args. So these are the arguments that go to Slurm that tell it how we want the job to run. So we want to first of all do essentially everything that we would do if we were having to do this in a normal job script. So we tell it which account to use. We tell it the partition to run on, which is going to be standard. I'm going to use the reservation that we have in place. So the reservation is, let me grab this. I've put it on here. I'll put this in the chat for you as well, in case you all want to use the reservation. So that's on the Etherpad. So the reservation means we also need to use QoS reservation. And then we need to provide the name of the reservation. So this is running on our special nodes that we've got for us just for today until 4 o'clock. And then it's just the other options. I'll just copy and paste these in. So we're telling it we want it to run for no more than 10 minutes. We want it to run with 1 task per node, 1 CPU per task, in exclusive mode. That's kind of a given anyway. And with export all means that it's going to carry through the environment variables from our current shell into the job. And now we can give the name to our task. So let's just call it here. We'll just do the same thing, myprog, and then in curly brackets 1. This means that we're within GDB for HPC, we're going to refer to this job as myprog. This is essentially a variable name, if you like, for this job. And the number in the curly brackets is how many tasks we're launching. So at the moment, we're just launching it in serial. And then finally, we tell it what to actually run, and that's GDB exercise. So we then press enter. It's now in the process of launching the job, so it should be able to grab the nodes straight away because we're using the reservation. Now it's creating MRNet communication network, so it's having to start GDB servers for the jobs and it's going to get them to connect. Because we're doing it in serial, it's pretty fast. If you do this to launch a debugging job with lots of tasks, it will be slow, and if you do it with more tasks, again, it will be even slower. So sometimes it can take a wee while to get going if you're doing it with 1,000 or more MPI tasks. So this is sruns our GDB exercise in serial. And it started, and we've got to an initial breakpoint. So at this point, it's up to us to choose how to start debugging. We can provide, here are a few commands. List, let's just quickly do list, show you, this just shows us the code in the original GDB for HPC exercise.c source code at the point we're at. So we're at the point where execution has halted. We're just about to run MPI init. We can run next to step to the next line in this file. We can do step, which will do the same thing, but if we hit a function or a subroutine, we'll step into that. Up takes us back up from that to the next to the calling function or subroutine. And then we can also do things, we can print variables, we can watch them, so we get a notification when a variable's value changes. We can do a backtrace, like so, to see what's our stack. And quit will just quit from it. Most of these you can also abbreviate, so you can do BT or L for list. You can just do single letter commands, and help will show you, well, it's wrapping a bit messily, but you can see here general descriptions of what all the commands do. So we've already run list. We've seen where we are. So we can now run next. Remember, we can just do that. Well, now I found out we're at line 13. If we do list again, we'll see we're now finding out our MPI rank within the MPI Comworld communicator. So so we can see count is a variable here. If we try print count just now, we get something a bit rubbish. It's not very helpful. It hasn't been given a value yet. But if we just run on a couple of lines, let's go one more. If we now do L, so remember L and N are just abbreviations for list and next. At this point, count should have been set. So if we try print count, we'll now find that it has a meaningful value assigned to it. And we could have used watch. We'll do that in just a second. So now let's just take 2 minutes. For those of you who are doing this along with me, let's just find out what happens if you keep on using next and list. So just moving forwards one line, seeing what the code is, moving forward to the next line, seeing what the code is again. Just give you 1 or 2 minutes to do that. And if you want to say what you find in the chat, please go ahead. I should also say, if you are trying to follow along with this and you do run into any issues, just as yesterday, please let us know. I'm here to help. We've also got Eleanor and Larissa are also here to help. If anyone's having issues trying to follow along with any of this work that we're doing, please do say so, and we will be very happy to help you get the problem sorted out. Okay, so I think we've had a couple of minutes there. So let's take a look at our solution. So we can see if we carry on, it will get to line 18. What's line 18? Well, that's an MPI send. And it's going to try and send a message, and it will then have an issue. So it will quit with an MPI error. So let's just try this. We've carried on. Next list. Next thing to do is MPI send. And at that point, we get a problem because it can't send a message because we've launched a serial process. Well, it is an MPI process, so it's able to make MPI calls. We launched it properly with srun, but with only one task. And so it can't make that send. So now we can just quit GDB for HPC. Now we're going to start GDB for HPC again. This time we're going to try launching across multiple processes. So we're going to start now with 2 tasks. So that should deal with that issue that we saw just now. I'm just going to quickly, I've just copied in the command straight from the material. I'll just edit it quickly so that I can run on our reservation. And copy that back in there. You can see it messes up the display a little when you go back to do that, but there we go, it's all okay. So I'll press enter, and now it's going to start a task. Something I should note is that you can actually see this running. So if you have another terminal logged in to ARCHER2, when you go through this step and you do a launch through GDB for HPC, you will actually see your task here. If you were to run SQ, you would see it listed as one of your jobs. Okay, so now we've got another exercise. We're running properly. We're running in parallel now with 2 MPI tasks. So what we can see is that it's trying to send count. So let's try watching it. So let's do watch count. And then we would just do again next and list. And next and list. So we'll just take a minute and see what happens when we do that, and then we'll take a look at the solution. Okay, so we've had a little time. So what happens when we do that? Well, we're basically at the important point here. So we can see we've just set that. If we go into next, we get a watch point alert. So watch points 1, variable expression count. That tells us that count has changed. If we do print count, we'll see that it's actually telling us 2 different values. So this is telling us that on process 0, count has got the value of 1, and on process 1, it's got the value of 2. If count had the same value on both tasks, it would have given us a range of tasks rather than list them separately, just to keep the output readable. But here it's got a different value on each of the 2 tasks, so it's telling us for each of them. So we've been told it's changed. Let's just carry on again. And let's do another list. We've moved to the next line. So you can see as well, when you do a next, it will tell you when the different tasks reach their next breakpoint, which is just the next line. So if the next line takes a while to execute, you might find that some tasks reach the next line quickly, Others take a little longer to get there. But here it's quite simple, so they both reach the next line pretty instantly. And you can see again, when I've run L, so an abbreviation for list, we've got different output for task 0 and for task 1, because they've now diverged in their execution. There's an if in that code that tells it to do a different thing depending on which rank the process has. So our rank 0 code is now going down the route of doing an MPI send, while our rank 1 code has gone down the branch where it's going to be receiving the message instead. So this is the next thing to happen. Task 0 is going to attempt to send, and task 1 is going to attempt to receive. And if we go to next, you can maybe immediately something's happening, because task 0 has reached the next line, but task 1, process 1, is waiting and seems to be having issues. So what's happened now, as we can see, task 0 has sent its message and it's now waiting. Well, it's going to wait at the barrier. Task 1 is trying to receive. This is a blocking receive, and it's not managing to move beyond it. So it's stuck waiting for that message. And the problems are that it's waiting for a message from task 1, which is itself, it's not going to do anything there. And it's also waiting for a message with a tag of 1, and the message that was sent from the other task had a tag of 0. So there are two small issues to be fixed here. So what we'll do is we'll quit the program once more. So we've at least found one problem to deal with. So let's just open our code, gdb for hpc exercise.c, and I'll just do it in Vim, of course. If you prefer Emacs or Nano or whichever your preferred text editor is, you can use that. So we know that our problems are just here. So one way we could try to fix it is to maybe just give this a tag of 1. We'll just change that 0 to a 1, and we'll tell the receiving task that it's got to instead look to get it from process 0. So we'll just change those two numbers like so, save it and quit. Then we'll rebuild it. So I'll just go back to my line to call the C compiler wrapper to build GDB for HPC exercise again. So that's been built. And then we'll try to run it once more in GDB for HPC. So I'll just start it again. I'll just copy and paste the same launch that I used previously, which was this one here, just so I can go a little faster. So again, launching with 2 tasks on our reservation. I'll paste. Oh, that doesn't work. Because it doesn't like the extra. It doesn't properly copy, I think, the line breaks. So I'll just do it this way instead. So I'll just quickly change that. So again, QoS should be reservation. And the reservation itself should be, oops, let me copy that across, should be that. And if I press enter, that should now launch the task. There we go, starting application. Then it will tell us about the MRNet network. You see, it's taking a little while to get started this time. So, okay, so here's our list. So this is where our code is. We've reached the first breakpoint, which is just at the beginning of execution. Both tasks 0 and 1 are at line 9. Let's watch count again. And then this time we'll just go through and we'll do next list. They've both reached line 13. They're getting their rank list. They're about to set count. We know that. And if we do next, we'll also see the watch point notification. That's good. Count's been set correctly. They're now diverging. Task 0 is doing the send and task 1 is doing the receive. Let's step forwards again. We've got another watch point for count. That's because the value is being changed now on task 1. Let's make sure. I think that was slightly premature of me. Our task 0 is 1. Right, yes. So now finally, if we just carry on a little bit further, we hit the second problem that we've got to deal with. So what's happened now is if you were to follow it through, then task 1 is, well, we can, actually I think I've gone a little bit too far here. Where are we? Yes. So what's happening now is that process 1 is trying to do the sum, and process 0 is hanging because that's now trying to do the MPI finalize. So there's still a bug for us to find, but it's but one of the tasks has gone into a function, so we want to now try and step in instead. So we'll release is another command. So we're shutting down the job, stopping that debugging, and we'll start the same thing again. Remember, $myprog just refers to that job. So we'll start another debugging job. This time, let's just call it myprog1. I think actually my new prog. You can call it whatever. So I'll just call it myprog1. I'll just choose to call it here just to show you. And that's now going to start another debugging session. And we just need to give that a few seconds to get the node for us and launch the 2 tasks and get the GDB servers running so that they can talk to one another and we can follow what it's doing as a whole. Okay, so we're going to do the same thing again, just as before, except this time we're going to use step rather than next. So let's just list again. We can see where we are. This time we'll do step rather than next. So this takes us into the function when we get to that point. So you see there was a slight delay. I typed step, then a few seconds later, half a second, this line appeared above the prompt to tell us that execution had reached that point. So I can list. See, we're now at the MPI com rank again. I'll type S, which is the abbreviation for step. Both tasks are still doing the same thing. I'll step forwards once more. They've both reached the next breakpoint. Okay. They're about to diverge from one another. They're now, the 2 tasks are on different lines. List again. One is doing the send, one is doing the receive. Let's step forwards again. They're both now at the barrier, which is good. So that will be able to complete. Let's step forwards once more. And now things are going a little differently because task 1 is now on a if rank equals 0 line. It's moved on, and this hasn't. So if we step forwards again, we can now find this one is going into that if block. Task 0 is going into that if statement. Task 1 is now at MPI finalize. Let's step again. We're getting nothing from 0, task 0, but that's now here. So let's see if people now, I'll give you a minute again, see if we can see where the issue is. Okay. So if we take a look here, we can see what happens if we carry on stepping. We can see for the first task is still doing something. We know that's actually waiting at the MPI finalize, but if we continue to step, we'll see that task 0 is going now, and we can check if we do, I think, backtrace. So BT backtrace, we can now see that task 1 is just still doing its thing, but task 0 has gone into sum even, which was the little function there. If we continue to step and follow what this is doing, we can eventually see that there is an issue here. You've probably already seen it. We continue to do this over and over. See that we don't ever seem to be getting anywhere here. We seem to be perpetually stuck at line 46. We can see prog 0, my prog 1, 0, task 0 is perpetually stuck at line 46 here, in this if. And if we take a look, we'll see, well, it's trying to sum all the even numbers, I think up to 20. There's an issue. It's meant to be moving through this loop as long as I stays less than or equal to the max value, then adding to the result if it's an even number, if I mod 2 is equal to 0, but then it's only increasing I if that if statement occurs, and that shouldn't be the case. So we can actually see what the problem is. We can see exactly what needs to be fixed. So we can quit, and we can then just vim our GDB for HPC, exercise again, and let's just delete that line there and add it there. So now I++ will happen on every loop through the while. It's a little messy, but I'll go with it. And if we rebuild it, well, I won't show you because that will now work. And we're behind a little. I think I'd like to move on to profiling tools. But if we were to then run that through GDB for HPC, just the same as before, it would then run through to the end and we would get a nice clean exit from the program. So that's one way to run GDB for HPC, which is to just start it up in an interactive session on the login node. You've just logged into ARCHER2 and start up GDB for HPC. You can also, as I mentioned earlier, you can attach it to a running job. There's an attach command you can use. So if there's a job already in Slurm running and you want to attach GDB for HPC to it to investigate it, you can do that. another way to launch it is a little like what we've just been doing, but you can start an interactive session using salloc, as we did yesterday afternoon. And then once you've been given your allocation, once your job has started, you can bring up GDB for HPC on your login node, and you can run a launch command, and you don't need to worry then about specifying your launcher args, because your job, if you like, has already started. So you can skip all of these arguments and just do launch, and then the name you're going to refer to the job by, and the executable to start. So that's sort of a minor convenience, I think, not having to write in the launcher args. Perhaps a bigger convenience is that if you're going to be starting and stopping your debugging sessions very quickly, you wouldn't need to wait every time for your job to start, particularly if the queue is quite full. You would wait once when you do your salloc to be given your nodes, and then until that job ends, you can launch, stop, launch again, launch, stop again on that job inside GDB for HPC without having to wait to actually get the job to start. The only waiting would be in the actual starting of the executable itself. So we'll move on to profiling tools now. So again, just as with the debugging tools, there are a good number that we have. CRAPAT is the main one, and CRAPAT Lite. So these are pretty full-featured profiling tools. As the name implies, they're all Cray developed. CRAPAT is the big version that you need to do a little work, but only a little work, we'll see in a minute, to get going with. CRAPAT Lite is very simple to use. Reveal gives you performance analysis and code optimization advice that comes out of actual runs. There are the Cray PAPI, I guess. I'm never quite certain how to say that, components. These are sort of components that go into it in particular to give you access to hardware performance counters. And Cray ARCHER2 is essentially a GUI tool to let you look at results that you may be able to obtain from the other components I've just been talking about. These produce output files, and Cray ARCHER2 will then load them up for visualization. So we're going to do some work here again. Oops, no such thing as two commas and a full stop. So let's just quickly make another directory in my work directory. I'll just call it perf, and I'll just cd into perf. And we're going to grab another program. This one's in a tar.gz file. So let's just download that. Via tar xzvf, that, or xzf, that file. That should extract it. Great. And there we go. So we downloaded the tar.gz, and we've just extracted it to the nbody par directory. So I'll move into that directory. You can see we've got a few C source files, an nbody header file, a slurm script called run.slurm, and a make file. So if we quickly check our modules with ML, we should see we've actually got something loaded already. We've already got perf tools base loaded. This is loaded by default on login to ARCHER2. And this is the base central components of CRAPAT, which are needed whichever CRAPAT tools you're going to be using. So this is loaded by default, but then to use any other, to actually use CRAPAT, you need to load more to do the performance analysis. So we're going to load perf tools Lite on top of that. We do ML, we've now got that. So perf tools base is supporting perf tools Lite. Now, as I said, perf tools Lite is very easy to use. So if we just run make, then we'll get our code being built. Fantastic. And then you can see there's this extra message at the end, info, creating the perf tools instrumented executable. So whenever you do a build, the Cray compiler wrappers again see that you've got perf tools Lite, in this case, loaded, and they hook into it and they instrument the executable. That means we can then essentially just run that job, and we'll be able to see immediately some performance information. I can't quite remember if our run.slurm, yes, so our run.slurm does need to be edited a little. We need to change the account. I will again change it to use our reservation. So I'll just add an sbatch reservation to the script and add our reservation name to it. And you can see again, OMP num threads we've set, and we're doing, you don't need to worry about this. This is just to actually run this n-body code that we're using as an example. Then if I do sbatch run.slurm, that will go into the queue. I can check it if I do TA043. There's my job, and it's running at the moment. And that job's finished. If you take a quick look at this, you'll see that we put our output, we chose to have our output from the job go into a slurm-out.txt file, and that's here. Now, if we take a look at this file, more slurm.out, actually, let's just make that less. Less is the better tool, but I always find myself going back to more for my hands just run away with themselves. Oops. There we go. Okay. Not quite sure why they thought it was a binary. So here's the regular output from the executable as it runs, just with nothing else. And then, because it was instrumented with CrayPat Lite, we get some extra information. So we can go down and we can see we're getting profiling information. So this is a sampled executable, sampled profiling test. So we're now getting information that's telling us from the sampling how often the execution of the program spent in each of these functions. We can see 83.8% of the time from the sampling, at least, was spent in compute forces multiset. This is grouped as being a user function. 14.6% of the time was spent in MPI routines. We can break that down. CrayPat Lite is telling us how much time is being spent in MPI file write all, MPI file open, receive, send, receive. It's telling us that 1.6% of our time was spent doing square roots. Then we get group, function, and line. So now it's breaking it down further to tell us how much time was spent in individual lines within, in this case, n-body parallel.c. And we can again see how much time was spent under MPI calls there, as well as a square root. and more. It goes on and on. You can get, there's lots and lots of information available here. You can scroll through and see whatever is useful for you for what you're trying to find out. And yeah, we can check that out with Apprentice too. Oh, sorry, if you could just give me a second. Sorry, just a second. There's someone knocking at my window. That's unusual. Okay, sorry about that. Okay, so we've been using CrayPat Lite, which is the sort of introduction to get going with your profiling. We'll now try using the full CrayPat, which gives us a little more control over what we're doing. So we'll unload Perf Tools Lite, and then we'll module load just Perf Tools. To then do this, we've got to make clean because we've got to rebuild our executable to instrument it. And that's been done, and then we will make it once more. What you'll notice this time is that when we were using Perf Tools Lite, we only had to do a make to get a message at the end of the make telling us that the executable had been instrumented. That hasn't happened this time because it's not going to automatically instrument it for us. We need to choose how to do that ourselves. So an initial instrumentation you can do by just running pat build and then the name of your executable, which is nbody parallel.exe. We'll run that, and then that does an initial sampling instrumentation of the build. And if we ls, we'll see that it's actually created this for us. So we've now got this file here, nbody parallel.exe plus pat. And this now, if we run it, will give us the sampling run. So we'll do run slurm, and we'll just edit the name of the executable that we want it to run to now run the instrumented executable, which has the plus pat at the end of it. And if we sbatch run.slurm and get that in the queue, we'll see that's running, thankfully. Our reservation is very handy. And just give that a second, and it's finished. Fantastic. And listen, you might have noticed when I did the ls just before, we're getting these directories now. So we've got this funny looking directory with the name of the executable plus 43524 512s, and now we've got a new one with a plus pat in it. So these are both the output directories. These contain all of the output information. This was the output directory from our CrayPat Lite run. This is the output directory from our new CrayPat run. So you can see we've got the name of the executable is the first part. This was the process ID when it was running. It's a way of identifying it. Then we've got a node name. So 1512 means that when we ran this job, this was running the 0th process, the head process was running on NID 001512. That's the name of the node. And the final S on both of them tells us that this was a sampling run rather than a traced run. So we've got our output directories. If we do slurm out, we can see whereas CRAPAT Lite had this information and then a whole load of information about the performance experiment. Now that we've run the full CRAPAT version, we actually don't have that performance information in the standard out file. So what we've got to do now is use pat report to get the information that we want. So the simplest way to do this is to just use pat report and give it as an argument the name of the directory with the output from the run that we want to know about. So we'll do pat report, and we can just give it as an argument the name of the directory created in the run from just now. We can just press enter for that, and it's just given us a lot. So let's try instead piping that to less. And now we can scroll through it and take a look, and we can see we've got essentially the same information as before. Actually, we've got a decent amount more as well. I don't think we got this information from Pat Lite. But that's only step one. So we can, rather than look at everything, we can choose to only look at certain parts of that output. So if we want to look only at the profile report by function, then we just say, give us the sampling profile, please. So we would do pat report, give it -v and the -o, samp profile, and then the name of that directory again. And now it's still going to give us some extra information, but it's only going to give us the one table, which is the profile by function. Again, it's breaking it down between user, MPI, math, some functions might come under, etc. So it tells us just the raw number of samples, the percentage going into each group or function, and then it tells us about how imbalanced that is across the different processes, the different MPI processes that we're running. So were some of the tasks, some of the processes making spending more time in those calls than others. If we want to get information on how it's broken down further into lines, how often was spent in, how much time was spent in given lines in the run of the code, then we would do a pat report again, but this time we would do samp profile plus src plus source rather than just samp profile. Oops. And we want to give it our directory again, and I've forgotten the name of that now. So we want to call it, yes, call it on that directory. Maybe I should be just piping that to less. So again, we've got this sort of standard header information, some help on how to interpret the table, and now it's broken down by group, function, and line. So we can now see how much time was spent in given lines within our parallel.c, in this case, source. And you can do the same again, but this time let's change it to function and callers with line numbers. You can probably see there are lots of options on how to do this. Just doing a man on pat report is a good place to start if you're looking to perform some task in particular. And we can go down again. And now we're seeing the call trees. So we can see, in particular, how much time was spent in a given function and how it was called. So that's how to use CRAPAT to get starting information, I'll call it, just to do an initial run, an initial sampled run. and to then use pat report to get the information out of the output directory that you can actually use to start working out how to approach your code. These directories that have been generated, so let's just look at this one, actually contain, as you can imagine, they contain things within them. We've got some more directories, AP2 files, buildoptions.apa, index.ap2, and another directory called xf files. You generally don't need to worry too much about the contents of these directories that are generated by ClayPat and ClayPat-Lite, other than this one here, buildoptions.apa. So APA stands for Automatic Program Analysis. So when ClayPat does that first run, it just does a sampled run, but it then generates this APA file, and this APA file contains a list of suggestions on how to make what should be a good traced run. So rather than just using sampling, we can actually trace a run now. One thing you can do is you can just do a run that's traced everywhere. This will contain recommendations on which functions in particular, based on the sampling experiments, should be traced given how much time is spent in them, while not tracing everything, just to hopefully keep the experiments, keep the testing from the tracing and from unbalancing things too much, from the whole issue of observations changing the outcome. So if you do APA, it's going to work out what options might be good for a traced run, which functions should be traced. And we can use that directly by just calling pat build again and giving it as input the name of that APA file. So if we give it build options APA, we're passing it through the so that shouldn't be a -0, that should be a -O flag. Oops, pat built, no, pat build. So that's now created, if we look, a new executable, nbodyparallel.exe plus APA. And we can then change our run.slurm script again. And we can change this to APA, and we'll now run that executable. If I go back to my SQ, that's running, excellent. Which you'll see in terms of how we use the output, it's essentially the exact same again. And that's finished running. And we'll now find that we've got a new directory. We can see this has changed. It's now got the name of the executable, including the APA at the end of it. The process ID is different, and that final S has changed to a T because this was a traced experiment rather than a sampled experiment. And we can get our pat report from this directory now and see the results here. And we'll find some potentially more accurate information now that this has been traced rather than sampled for us to use. There are many more things to look at, so I guess, yes, the hardware performance counters, we could take a look at that if we wanted to. Sorry, I do realize we're overrunning a little here. So profile plus HWPC. And I'll pipe that to less as well. And now we get information on cache usage and memory traffic and more. L2 prefetch hits, L2 prefetch hit L3. Yes, so I think what we'll do, given it's already nearly 11:15, and this should have been when we were coming back from our morning break, is I will call the morning break there. So we'll break now, and we'll come back in 15 minutes at 11:30, and then we'll have I suspect that the next session maybe won't take as long as it needs in the timetable. So, in fact, maybe both of the next two sessions. So hopefully we'll still be able to get to lunch about on track. I'll see if we can make that happen. But just for now, I'll call the break. So if you want to go and get something to drink to keep you awake, I should probably do that at some point. But what I'll actually do just now is, for those of you who are interested during the break, I'll just quickly show you how to do this last part here, which is interesting. If you want to use Apprentice2 for to graphically examine the results of one of your runs here, it's quite simple to do. I just need to open a new terminal with X forwarding, because I haven't done that just here. So I'll just quickly start a new terminal and log in, and then I'll move that over and just quickly show you how you can take a look at your results with Apprentice2. Okay. So, get rid of that. That need exports. Oh dear, I'm out of date on my exports apparently. Okay, so here is a terminal, and I've logged into the wrong account. Let me just quickly bring that back. Okay. You'll see it's actually quite simple on how to do this, but I just like the chance to quickly demonstrate Apprentice2 during this bit of downtime. Okay, so hopefully you can see my new terminal here, which should have X forwarding enabled. That just means logging in if you're on Mac or Linux with the -X flag. And okay, so let's just check. Okay, so let's just go to the work directory, 043, TA043, and then my one is here, and we'll go into perf, it wasn't it, and nbody par. And let's just take a look at the output of this, of our latest APA tracing experiment. And all we need to have loaded is the PerfTools base module, which is loaded anyway when we log in. And I'll just do app2 is how you start Apprentice2 and give it the name of the directory. And this you should see has just started Apprentice2. And so we can take a slightly more graphical look at what's been happening during our run. Let's close about Apprentice2. So unfortunately, because you're doing all this remotely, this is all running on ARCHER2. GUI-based programs aren't the most interactive. I'll say things can be a little bit slow to respond. But we can take a look. We can see the breakdown of calls and time. So we've made many more calls to MPI send receive than we did basically anything else, but most of the time was still spent in main. Take a look at activity over our different processing elements. So this PEs basically means our different MPI tasks. You can see we had 64 of them. We can see that, well, process 0 is the one that was kind of different from everything else. Everything else spent a good amount of time, we can see here, doing synchronizations. Process 0, on the other hand, had to do a decent amount of time doing data transfer. So there's definitely some imbalance there we can see pretty quickly in how things were happening between them. We can also take a look at the call tree and see how we're taking a look here at how time was spent across the different functions that were being called and how that's broken down. So this is a pretty nice tool to experiment with if you want to take a more graphical look at things. I'll just leave that up there for now. But otherwise, I suggest everyone goes and gets something nice to drink, and we'll start up again with the next session at 11:30. Okay, I'll see you then, just 10 minutes time. Hi again, everyone. I hope you're all able to enjoy that short break. So we'll carry on now with our next session, which is sort of more general advice on how to be a good citizen, as we say on ARCHER2, which is really about how to be responsible when using a shared resource and how to protect your data. So we'll be doing this, and then afterwards, just before lunch, we'll also talk a little about how to use the safe. To get started with this session just now on how to be a good ARCHER citizen, ARCHER2 citizen, we'll get going. So the first question that sometimes needs to be asked is what you're allowed to do and what you aren't allowed to do on the login nodes. This is something that changes a little from system to system because of the way ARCHER2 is set up. There may be some restrictions here that aren't on other systems you may have used in the past. Something we should note, so to start off with, is that the login nodes are often very busy. We do have, I'm not certain of the numbers, but I believe we have something like coming up on 3,000-ish, I think, actual usernames. So that's not going to be 3,000-ish coming up on actual users because lots of people have multiple accounts. But certainly the number of people using ARCHER2 is in the thousands. So often we'll have many people logging in, creating files, editing source code, doing pre-processing, doing post-processing, building codes, debugging codes. This means that unlike some systems you may have used, we don't really allow we don't allow what you might call heavy computational tasks to be run on the login nodes. You'll generally get poor performance anyway because of the restriction on resources that comes with having so many people on the login nodes to do their work. And very notably, you cannot launch parallel tasks at all on the login nodes. So anything parallel has to happen on the compute nodes. I mean, even of course, then you can still run CPU-heavy serial tasks, something which is going to maybe run for a long time, use the entirety of a core. We do allow what you might call a quick test. So this is obviously it's slightly subjective, what you might call a quick test and what you might call a CPU-heavy task. Generally, we say a quick test might be something that you would run. Again, it has to be in serial. It might be something that you would run for around 5 minutes-ish or less. So maybe if you've just built some small task and you just want to check, does it run at all without having to get a compute node reserved for you to test it the same or to run, to submit a batch script to the queue. You can just quickly start something up, see it works, and then quit out of it again. And if you do, so the reason that we say it really should be short is because if we have a lot of people doing this, then other users may start to be affected. You would generally see this as login sessions running slowly, or freezing or hanging, or the file system becoming unresponsive. So yeah, so this is kind of the critical points being made here, is that ARCHER2, the login nodes included, are a shared resource. It's for thousands of people who have access to use. So we'd ask that everyone please try to restrict their activity while on the login nodes to make sure that the other users are able to also do what they need to do at the same time. If you do find yourself occasionally running things which you don't intend to, it is possible to accidentally, to unknowingly start things that do go on to consume more resources than you're expecting, and it can easily be a bug as much as anything else. If you do find yourself in the spot where you need to find out what you're running and kill it, you can use the psux command to list the processes that you have. And you can then, once you've found the process ID for any tasks that you want to kill, you can just pass them along as an argument to the kill command to terminate them. It says just below, if you experience performance issues with a login node, you should report it to the service desk for investigation, so we can pass that along. If you send in a message, we can ask the systems team or HP themselves to investigate directly what's happening. As well as you should not use ARCHER2 login nodes. Yeah, so anything, any connection to our ARCHER2 should be going into ARCHER2 rather than out again. I'll add as an addendum to both of these points above and below our little exercise here, which we'll do in just a second. Sometimes as well, if you do accidentally launch something with a bug and you find that you can't kill it, and it can happen, you may find yourself running something and being unable to stop it, if for whatever reason, that would again be another situation where you would email the service desk and we can ask the systems team who have root access to kill it themselves and stop that from causing problems. If you do get in that situation, I would say please don't be embarrassed or anything. It happens. Everyone runs into issues like this. So if you do find something not working, not happening as you think it should, and you need it to be dealt with by someone with root access or whatever, please do get in touch, and we'll be more than happy to sort these sorts of problems out for you. Now we've got this little exercise here on login node etiquette, so talking again about which sorts of things would be okay to run and which sorts of things wouldn't be okay to run on the login node. We've just got 5 examples. A Python script running something called physicssim.py. A make, so we're building something here, we're compiling some code. Running a script called create directories.sh, sounds like it's going to be maybe setting up data ready for a run or something, possibly. What looks like an executable, which we've called molecular dynamics 2. So it's going to be doing some molecular dynamics runs of some kind, it sounds. And finally, we're going to be extracting a gzipped tar archive called r3.3.0.tar.gz. So let's just take a couple of minutes, ask people now to have a look at this and see which of these. You can just type the numbers in 1, 2, 3, 4, 5. Just type them in as answers into the chat, and say which ones you think would be okay, probably to run on the login node. We'll just take 2 or 3 minutes for that. Okay, so we've got one answer, 2, 3, and 5. So that's the make, the create directories, and the tar extract. Someone else? Okay, that's good. We've got lots of answers coming in. 2, 3, 5, 2, 3, 5, 1, 5, 3. Okay, let's just give it another 30 seconds, a minute or so, see if anyone else has any suggestions. I can see generally some of these, I can see one definitely doesn't seem to be favored. That's number 4. People seem to not like the idea of running. Another 2, 3, and 5. Anyone? Does anyone fancy running molecular dynamics 2 on the login node, I wonder? All except 4. Yeah, I think we're about there, aren't we? So let's take a look. So Python physicssim.py, number 1, is likely not going to be okay. So it can't be serial. It can't be parallel. Sorry, it has to be a serial one. But chances are, I mean, something called physicssim.py. Of course, we can't actually. We only have the name to go on. But it sounds like it's going to be some kind of simulation that's probably going to take a while to run. We'll probably be using 100% of one of the cores for, I'm going to guess, probably considerably more than 5 minutes. So you probably wouldn't want to run physicssim.py through Python on your login node. Even though it's just Python, it still has the ability to use resources. Make is probably going to be perfectly fine. Most people will be doing their builds on the login nodes. It uses resources, but because generally you're building lots of small files, it's easy for the processes to weave in different threads between them. So this is generally going to be okay. Something that people will do, if you've got a build that does take a long while, is you may prefer to run a build as a job. And if you've got a build that maybe takes even just an hour or more, people may choose to run the build through a job just for the convenience of it, so they can leave it and go and do other things. If you're starting it at the end of the day, you may want to pack up and go home and not have to think about whether your job's going to finish in time for you to leave or not. Wonder whether your build is going to finish in time for you to leave or not. So you might choose to run it as a job instead, so you can just let it run on the compute node, and then that's it done. create directories.sh. Managing data, again, is one of the tasks that the login nodes are meant to be there to perform. They're meant to be there for you to log in, get your runs set up, and creating directories, moving data around. That's all part of that. Molecular Dynamics 2, like number 1 with physicssim.py, Molecular Dynamics 2 sounds like it's going to be running some kind of simulation that chances are will be resource intensive in some way. It's going to use compute power, it's going to use memory. It's probably not going to be good for the login node. So we'd ask that something like that not to be run there. Finally, extracting a tar.gz file. I hope that's okay because you've already watched me do that on one of the login nodes this morning. So that thankfully is something that's fine to do. Again, just like number 3 with create directories, this is part of data management. This is part of getting runs set up. It's not resource intensive. It would be fine to do. If the archive is very large, however, so potentially, potentially tens to hundreds of gigabytes, perhaps maybe even more if you have some really large tar files, some large archives, then you may prefer instead to run that as a serial job on a data analysis node. Just again to have it run as a batch script, so you don't have to worry about it, and to make sure that the resource is needed, that the extra memory perhaps needed for that is there. But really, in principle, just from looking at them quickly, the two which look like simulations, 1 and 4, are probably not going to be okay, but the code build, creating directories, and the archive extraction should be fine. Okay, let's move on a little bit. Something I mentioned yesterday in passing, I believe, early on in the day, is about sharing login credentials. This is part of our duty, I guess you would say, to try and keep ARCHER2 a secure system. So we ask that you don't share your passwords or SSH keys in particular, account name if possible, with anyone. Basically, you shouldn't be allowing other people to log in with your accounts. Sometimes I know sometimes it's thought of as being easy if, say, PhD students and their supervisors say share accounts because they have access then to the same code and the same data. They can look at that and help one another. Or indeed anyone who works in a research group sometimes thinks it might be easier to just share accounts. But that unfortunately really does lower the security of that account. The moment that your SSH private key leaves the machine that it was created on, it's potentially not secure anymore. So if we do find out at all that that's happening, we would ask the people doing that to please reset all their credentials. So new SSH keys, new passwords. Okay. Yes, and if you do want to make sharing data easy, sometimes people do just forget or not realize that those shared directories do exist. So remember if you go into your sub-project directory, we talked yesterday, we've got the shared directory in here. Please remember always you can put whichever data or source code files you want into this shared directory, and anyone else in your project who might need them can quickly access them. if you do the shared directories, if you use the shared directories on the work file system, you can even run jobs there. So please make use of the shared directories rather than sharing full accounts. Next one is kind of for your benefit, I guess. So this is about testing before scaling to really big jobs. So this says, remember that you're charged for usage on ARCHER2. So you're probably all aware that just now on the full system, we aren't charging usage. So any jobs you run at the moment on the full system, when the job ends, and it would normally deduct your CU, the CU cost of that job from your budget, it is currently not actually doing that. You do still need to have a positive budget for the job to start, but at the end of the job, the cost isn't deducted from the balance. That will, of course, change at some point once the system passes this current sort of initial trial period. And at that point, jobs will be charged. So at that point, if you can imagine making a mistake in your job script, and you could potentially lose a lot of your CU balance through a mistake like that. So you might, the examples here are having a job script do nothing for 24 hours on 1,000 cores. So that's quite a lot of resources. And if it's using those, if it's been reserved those nodes to do that work, and it keeps those nodes to do that work for 24 hours, it will be charged 24 hours times the number of nodes allocated for the job, even if those nodes aren't actually doing any work, because they've still been allocated for the job. That's what counts in terms of the job being charged. Or maybe you make a mistake in your script and you ask for 2,000 cores. Again, that's a lot of resources that you'd be using, but perhaps your job script has a mistake and only 100 of those are being used. Again, you'd be charged for the use of a lot of resources, even if you're only using some small portion of them. Sometimes people write job scripts that automate themselves. So sometimes people write bash scripts to create lots of job scripts and then submit them all. When this happens, the jobs have to be charged because the nodes are there. They've been allocated for jobs. But if there is a mistake, that means you aren't getting the full use of them, then you're being hurt because you're being charged for jobs that aren't actually helpful. And other users are also being hurt because those nodes that are sitting there doing nothing are allocated, even though they could be used for other jobs which would be producing useful work. Sometimes the cost is in terms of your time sat waiting for the job to start. So an example here is you may wait in the queue for your job to fail within 10 seconds. Perhaps you write a job script and you ask for some large number of nodes, so it would be waiting in the queue for a long time, and then the job finally starts. It does the module loads and the like, and then it does the srun, and you typed in the name to the executable wrong, and it would crash and fail. You would potentially be waiting, who knows, hours, maybe even if it was a very, very big job, maybe even a day or more, perhaps, for the job to start, and then it would crash out straight away if you made a typo or a similar error in the script. So using the test queue would be a good idea there. So you would run, say, a very short, a very small job using the same resources perhaps, or the same launch method, just to make sure that everything works. There are some tools you can use to check the job script itself, to check the correctness of it at that level. But then once you're past that, you would then try submitting a short job to the short queue, say the short QoS, and make sure that it starts. It can start the parameters are set correctly for the run, that the parallel job launch happens as you expect, that it can read the data correctly. Another source of error sometimes is if something's trying to look for data on the home file system. Remember, that's not accessible on compute. That's another reason things can sometimes crash. So testing things work with small versions, small short jobs, to make sure that everything is working correctly beforehand is a good idea before you then submit the full calculation to run. So for a large run of jobs, try running just one rather than your full suite of jobs to make sure that at least that one test works as expected. And before running a very large or very long one, try a truncated test. And at a lower tolerance or a larger tolerance, or run for a shorter Tmax or the like, just to make sure that it works as you expect before you start burning those CUs. As we talked about yesterday, having a data management plan is an excellent idea. Having a backup plan is part of that. Home, remember, is backed up for disaster recovery purposes, but only disaster recovery purposes. The work file system isn't backed up at all. It's high performance. It's just meant to be used as high performance Scratch file system, Scratch storage for jobs, not for long-term storage. The idea here is that an individual's data is their responsibility here. So if there's anything that's absolutely critical for you, you should make sure, have a copy of it on your own laptop, have a copy of it on the cloud, on a hard disk at work, a hard disk at home, if it's really critical. Something else you can use are version control systems, which have cloud counterparts. So GitHub and GitLab for Git, or Bitbucket perhaps, if you're using Mercurial or the like. These are great for just storing source code and allowing you to roll back. I know some people still aren't that fond of version control systems. During my PhD supervisor, I think, was still sort of catching up to this. We were trying to push it, but we're still getting there. But yeah, these are very useful tools to have for just keeping backups of your code, being able to roll back through old versions of your code. This can help with just about everything. And it's very nice to have a free cloud-based backup for your code. For data itself, this is probably where you want to be using rsync to move that data onto local storage, whether that's disks in your personal machine or local storage at your institution. Something else to note is that your access to ARCHER2 may well be time limited, meaning that your project will probably have an end date. Not all projects, but a lot of them. So you should make sure that you have a plan in place for getting your data away from the system before that project ends. In particular, if you've got a lot of data, it's potentially a nasty surprise if you realize that your project is ending soon and you've got 2 terabytes of data to move away. That could take a lot of time if you're trying to move it over potentially a not fantastic network connection. So being prepared to do that ahead of time is a very good idea. We've spoken a little already about managing and transferring data. We spoke earlier about the costs of moving lots of small files, so it's how it's a good idea to put them into an archive instead, how you may want to choose to disable encryption or use a faster encryption method. So you can go back and check that, or there's more on the ARCHER2 documentation just there. And part of this all folds into, again, how to transfer data. So yeah, again, data transfer speed, you can be limited at several potential choke points along the way, I guess, several bottlenecks. This speed is one of them. So the few times how work is a highly parallel, it's a high performance file system, the ARCHER2 work file system, has a lot of good high performance disk drives in a big Lustre array. So this gives them a very high data bandwidth. You can imagine this has to be the case if we're again talking about potentially, thousands of people running jobs, and all of them are working on preparing data or building software on the login nodes. There are jobs running, outputting potentially vast amounts of data onto the file system. So the work file system has a very, very high data bandwidth. Unless the place that you're transferring the data to has a similarly parallel file system, so unless that's running Lustre or the like as well, then if everything else is fantastic, if there aren't any other bottlenecks along the way, you may find that it's the disk speed on the receiving end that's limiting performance here. And Andrew's just made a comment. Yes, you may not want to, so if you're using cloud-based backup, you may want to make sure that things aren't going public if you don't want them to. That's a very good point, Andrew. Definitely. And in particular, yes, if you have an NDA or the like in place, that would definitely be a no-go then. So yes, so if you're using cloud backup, make sure that it's being stored appropriately for any concerns you may have about privacy, or whether the code should be kept private through any other mechanism. So metadata operations really come into play if you've got lots of small files to be moved. This is the metadata is the information about files rather than the data within the files themselves, such as the owner, the size, the permissions on the file. They're actually stored on different hard disks on the Lustre system. There are different metadata servers to contain that data. So if you do find yourself, if your typical applications do write many files, I think a program, I think off the top of my head, that does this is OpenPhone, can output many files. Then when transferring, if you're transferring those files individually, that could become your limitation, your bottleneck point, getting the metadata for those files. So that's when you may want to instead archive the files into a single archive which then has only one set of metadata associated with it. Network speed is obviously is probably the most obvious potential bottleneck here. ARCHER2 is on Janet, and it's got a very good connection to Janet. So if you're trying to transfer data to a personal system in particular, probably that's likely to be the bottleneck. Wi-Fi in particular is generally not as great as a wired Ethernet connection. So if you do need to transfer data to a personal machine, it might be worthwhile to just quickly get out an Ethernet cable and plug directly into your router. If you're doing it to a local local storage at your institution, then at least in the UK, chances are you're in Janet as well, and hopefully the connection would give you enough bandwidth to get that data across quickly. Finally, the firewall speed can also be a factor here, as that introduces overhead as it filters packets that come in, and that can reduce your data transfer speeds. This is really because general purpose networks are a little different from what you might really want for a firewall, protecting something like a large storage system that supports lots of data transfer. So it may be worthwhile if you're trying to do this. Again, this applies more if you're copying data to your own personal machines at home. It's possible that tinkering with your firewall may give you a boost to performance there. Really, though, I think probably the most general advice to give that would help in all of these circumstances is to archive before you do the transfer, because this cuts out the overheads in metadata performance. It cuts out the overheads in the transfer protocols used by SCP and rsync. It just cuts out a lot of the overhead that's would be needed if you are moving individual files, and just quickly tarring or zipping something without even compressing it will help to speed up that data transfer. A few tips. Something you may want to do is to just run some tests beforehand. So you could try tarring up some of your files to make a big file, just so that it will run long enough to give you an idea. Start transferring that, and take a look at what your download speed is, and you can then work out from that point how long you think it will take to transfer the full data set, and then you can plan accordingly for when you should actually do that as part of your data transfer, data management plan. And yeah, as we've said a few times, if you have even more than just a few files, if you have many files, it's a very good idea to archive them first before the transfer. A few key points. I didn't write this, but I find this kind of amusing how much they try to bash it into us. Key points number one, be careful how you use the login node. Okay. Second point, your data in the system is your responsibility. Third point, again, don't run stuff on the login node. That's maybe a bit broad. You do need to run some stuff on the login node, just not anything taxing on the login node. And fourth point, again, don't be a bad person and run stuff on the login node. So hopefully that's kind of getting the point across. Okay, and with that, we'll just quickly carry on to the next section. We'll get through this, I think well before 12:30, which is when I was thinking we might go for lunch. This is just a little on how to use the safe. We've spoken a little on it. This will hopefully give you some more information on how useful it actually is. So all of you will have had some experience with the safe when getting your accounts, whether training accounts for this course or your other main accounts on ARCHER2 if you have them already. So you'll have gone through the website, you'll have signed up for an account on the safe website, and then once logged into that, you'll have used it to request your login accounts on the machine itself. But it has a whole suite of functionality that possibly you aren't aware of. So we'll just go through a little of that now. Something that is useful here is a link to the safe user guide. If you'd like to see more about what sort of tools and features are away in the safe, you can take a look through that. Particularly if I think sometimes people aren't aware of how to set up the sub-projects and the like, but they maybe would think it would be useful. So if you aren't sure about project management, this is also covered in the safe because that's all managed safe side. So account management is what we'll all have some experience with. We've all done this, as I've said. We'll have at least 2 accounts associated with our use of ARCHER2. The safe account, which we used to get onto the website, and then once we had that safe account, we requested our ARCHER2 login, sometimes called machine account. And what you can do is, if you've got multiple accounts, then they will all be there on the safe. So you can have multiple ARCHER2 login accounts associated with a single safe account. In particular, you may have accounts under different projects, in which case you would see them all on there, and you can manage all of those from the same safe account. A lot of you may also have access to tier 2 resources. I think we're now managing a few other systems through the same safe as well. The main one, I think, is probably Cirrus, which we also run here at EPCC. So if you have Cirrus accounts, chances are you've also got those on the same safe account. Sometimes, again, people aren't aware that they can have multiple machine login accounts on the same safe account. So I think sometimes people occasionally end up with multiple safe accounts, but you don't need those. To get a new machine login account, you just need to log into the same safe account that you had before, go to the accounts button along the top toolbar, you mouse over that and a little toolbox drops down and you can click on request new login account. And that's where you can just add as many login accounts to whichever machines as you need. So yes, so there are lots of options available for you to choose on your safe account. I mean, there are options associated with the account itself. Personal details are a big thing because this is how we know who these accounts on the machine belong to, how to get in touch if need be. These all come in as part of us knowing your contact details. This lets us record the research outputs associated with the use of, in this case, ARCHER2. That's good, so that EPSERC and NERC and the like know that the system is being used what it should be used for. As for getting access, some of you will be using an institutional single sign-on. This does require you first to log in normally, and then you can go along the top bar to your details and then to register institutional ID. where you can add that SSO login to your account, linking it, and then you can use that to log in rather than use a separate password for the safe. If you use a password manager, that will hopefully, that should be filling in the password for you automatically on the login page. But if you do find it easier to just use an SSO login, that's an option available to you. It's also important sometimes to be aware of your email preferences. A good number of emails go out every week or so. I think it's generally at least once a week. There's a message sent out from UKRI providing information to the users. Sometimes people don't turn these on. I would recommend personally always having all the emails turned on, because very useful information can come through. Whether it's change in how to log into the system. For example, when the login to the 4-cabinet system changed its URL from login.archer2.ac.uk to login-4c.archer2.ac.uk, this sort of information comes through in these emails. So keeping up to date with what's happening on ARCHER2, being aware of changes to the system on how to access the system. This information should come through in these emails, so I'd recommend having them turned on. And also, if there's any upcoming maintenance, it can sometimes be annoying if you are planning on doing some work and you clear your morning on Wednesday or whenever, and then you find out that you can't actually log in because the system is down for maintenance and you weren't aware. So I would say keep your email notifications all turned on so that you can stay on top of what's going on the system and plan your time accordingly. Checking your login accounts, and this is actually a little more general than just ARCHER2 login accounts. Any Cirrus accounts or accounts in the other systems will also be visible in the same way. Once you log in, you can check the login accounts menu along the top bar of the website, and then you can choose a particular one. So an ARCHER2 login account will be user ID @ARCHER2. This will bring you onto a new page. The important things to note are that on this page, you can see directly your available resources. The main thing that everyone will be able to see here are the budgets that they have access to. So the different sub-projects and projects that they have access to under this account, and how many CUs they have. So that's your compute allocation, remember, your compute unit, each equal, remember, to equaling 1 node hour. So you can check there directly which projects you have available and how many resources, how many compute units they have. At last tally from Slurm. You always want that to be positive, remember, of course, if you want to run jobs. And if your project manager has also set any storage quotas on the project, you'll also see there how the disk usage is looking. So this should be your main place to come to if you just want to check what your resources look like. Something else you'll also see here is a list of any licensed software that you've been able to get added to your account. This is also the page you'll have come to when you wanted to get your initial login password for ARCHER2. This point here, this can sometimes catch people out, is that the password given when you come to this page is not your actual password to use to log in after you've changed it for the first time. This is only an initial login password. So you will come to this page to get your password to log in for the first time, then you'll log in, and change the password to your choice. Remember, not my password and not horse battery staple. And once you've changed it to a password that you and only you know, the password given on the safe will not update. That will stay at the same initial password, except of course that password is now meaningless. So yes, at this point, only you will know it. It's not on the safe, only you are aware of it. But if you need to reset the password, which is the next point, you can come again to this page on the login accounts menu for your account, request a password reset. You'll probably have to wait maybe 10 minutes, 5, 10, 15 minutes or so for this to go through the system. And you'll then be sent an email to tell you that a new password is available for you. Then you do come back to this page, check the View Login Password button again to retrieve it, and then it will just be like you were logging in for the first time again. You can use that password to log in, change it, and then you're ready to go. Yes, you can also add more SSH keys here. If you intend to log in from multiple machines, or perhaps even if you're running VMs on your machine and want to be able to log in easily from those, you can simply generate a new SSH key pair. Please remember, I've said before, but please remember to keep the private keys local. Don't ever move them away from the machine you created them on. But to use the public key, you just come onto this page on the safe, and you can either upload the file directly into the safe here, or else you can copy and paste the text of the key into the text box and add it. Again, you'll need to wait 5, 10, 15 minutes or so, and then an email will come through telling you it's been added to your account, and then you can log in. So yeah, you can potentially have loads and loads of keys added if you want to log in from lots of different machines, lots of different VMs on those machines. Finally, it's this page you come to if you want to get access to licensed software, so say VASP or CASTEP or the like. You can just come here, click on this button, choose the piece of software you want to be able to use. You'll then get some instructions. This depends on the software. Different pieces of software have different licensing methods. So VASP will ask you to provide the name of the license holder. So probably the PI in your research group, possibly you yourself, along with that person's contact details and license number, and you would then send this information in that's created as a query internally for us, and we can then check with the people who manage the licenses for that software whether we can give you access. Once they've given us the okay for that, we then enable access by adding you to the package access group, which means you then are in the group which has read and execute permissions on that software. I mentioned earlier how recording the research output is good, because then UKRI and the UK government can be certain that this is actually a good way for them to spend money, that you are able to do good work using ARCHER2. So whenever you get something published, you can upload a DOI for your output, and this will then gather the information, it collates it, and we can hopefully use it to help continue convincing the government that this is a worthwhile use of their resources. Finally, something which is useful, something I think that project managers possibly get more use from, but you may still find it interesting, is to check on your use of the service. So if you're just a user in a group, you can just go ahead, you can go to the service information reports menu item, and then you can look up things like the use of the disk, use of how many jobs have been run, your use of CUs, to keep track of how you've been using the system over time if you're trying to manage this. If you're a project manager on the safe as well, you can do this for individual projects. So you can go to the projects menu at the top and then pick a project and then check the reports on how your various users within the project are using the resources available to them. And you can output, well, you can go for a preview in HTML, but you can also output PDFs for use. This produces graphs of the data, and you can output it to CSV if you wish to do more processing yourself. Okay, we'll end there unless anyone has any questions. I think we'll still take the full hour for lunch. I think let's check the schedule. We were originally due to break for lunch at 12:15 and come back at 1:15. But this afternoon is quite, I think, light on how well we need to keep the schedule. So I'll say that we can just break now and maybe come back at 1:30 from lunch to get started again. And then we'll be talking a little more about the next steps to take using ARCHER2. And then the final session we have this afternoon is a bootstrapping session. So we have some GROMACS data available that you can download and copy to your accounts, and you can start trying to run that, trying to profile with that, check how well it scales. Or if you want to do something else, you can also attempt, if you want, to bring your own code onto ARCHER2. You can try to build and run that, and Eleanor and Larissa and I will be about. So if you want to try getting going with your code on ARCHER2, we will be there on hand to help you directly with any questions you may have or help with problems you may run into. So if you maybe want to start thinking about that, what to do this afternoon, hopefully we can be in a good position to help you out with your choice, particularly if you do want to try running your own code on the system, build and running your own code. Okay, so I'll hang around for 10 minutes then, in case anyone has any questions just now. Otherwise, enjoy your lunches, and I'll see you back at 1:30.